So the next section we're going to cover is linear functions and direct variation. You already learned that the vertical line test is used to determine if a relation is a function. So if you draw a vertical line and it hits more than one spot, then the graph is not a function. If you determine that it is a function, then you can also determine if the function is one-to-one. So first you must say, is it a function? You have to do the vertical line test, determine if it's a function. If it is a function, you can do a horizontal line test to determine if it is 1-to-1. So if we had the graph of 2x minus 1, first, is it a function? Yes, because it passes the vertical line test. Is it 1-to-1? Yes, because it passes a horizontal line test. So you could draw vertical lines. It would only hit one time. You could draw horizontal lines. It would only hit one time. So this function is 1-to-1. Next page. So let's look at some examples. First one, linear function. So you have to ask yourself, is it a function? Yes, because it passes the vertical line test. Is it 1-to-1? Yes, because it passes the horizontal line test. Second one, y equals x squared, parabola. Is it a function? Yes, because it passes the vertical line test. Is it 1-to-1? No, because it fails a horizontal line test. If we drew a horizontal line, it would touch in more than one spot. So it is not 1-to-1. Last one, absolute value of x plus 3. Looks like a V. Is it a function? Yes. Is it 1-to-1? No, because it does not pass the horizontal line test. Next page. Okay, the last thing that we're going to talk about is a function onto. So, does it pass a vertical line test to determine if it's a function? Does it pass the horizontal line test to determine if it is 1-to-1? And now the last part is it onto? To be onto, the domain and the range have to be the same. So remember, the domain is the x values and the range is the y values. So first graph. Y equals negative 183. So that's going to be down here, negative 183. The domain is all real numbers because you can put in any value for x. No matter what value you get, or put in, sorry, no matter what value you put in, you will always get negative 183. So the range is just negative 183. So is this graph onto? No, because the domain and the range are not the same. Next function. Y equals 5 minus x. Domain. Is there any x values we can't have? We can plug in any value for x and get a corresponding y value. So our domain is all reals. Our range. Are there any y values that we don't get? No, we'll get all y values. So the range is all reals. And so this is onto, because the domain and the range are the same. Next graph is a rectangular hyperbola. The domain is everything but 0. Notice that if I put 0 in, I can't do that because 1 divided by 0 is undefined. So the domain is all real numbers except for 0. So just think, what makes the function undefined? 0 is the only thing, so that's what you can't have. What's the range? What are my y values? So you're looking, going up your y-axis. Do I get values here? Yes, yes, yes. Only spot I don't get y values is on the x-axis. Going up after that, all the way up, I'm always getting a y value. So the range is all reals except for 0. So again, the domain and the range are the same, so this function is onto. Last graph. So in this graph, the domain, look at your x values. Can you get anything here? No, the graph doesn't start until after -1. So the domain is x is greater than -1. The range, where do the y values start? They don't start until after 0. So y is greater than 0. Are the range and the domain the same? No. So it's not onto. So the two main concepts from today's lesson are, is a function one-to-one and is a function onto. So you want to memorize, how do you find out if it's a function? Vertical line test. How do you know if it's one-to-one? Horizontal line test. And how do you know if it's one or onto? If the domain and the range are the same. That's all for today. I do have a joke of the day for you. What do you call a fake noodle? Answer, an impasta. See you in class.